Yeah, everyone. Just a quick video. This one is just really just giving you a couple of formulas for finding the angles between things. I'm not going to do an example because once you see the formulas, you go, "Oh, I know how to do that." It's something we've sort of covered a lot in different videos. Okay, so this one we're going to look at how to find the angle between a line and a plane, and how to find an angle between a plane and a plane. Okay, so that first one, the angle between a line and a plane. You'll see that if you're trying to find the angle between the line and the plane, and just to go back, remember that cos theta is equal to a dot b over magnitude a, magnitude b, etc. That's the base formula that we're using. So here we're trying to find the angle between the normal and the direction vector v, so between this guy and this guy here. So we're trying to find the angle between those, but because the normal is not in line with the plane itself, we actually switch between cos theta and sine theta. So we go to sine theta because we want the other angle. So because the normal is going upwards, because the normal is going up that way, but we don't want that angle. We want this angle here along there. So we want the direction of that. We want the angle between those two. And so what we do with the formula is we switch to cos. From cos to sine. Okay. So what we end up with is sine theta. So the angle between the line and a plane is just equal to v dot n. Again, we take the magnitude of that, so we get the acute angle over magnitude of v and magnitude of n. Okay, so that's just simply our formula. So just to explain again, because the normal is perpendicular to the actual plane itself, that's why we've switched to sine theta for that particular formula there. Hope that makes sense why that change has happened. It's not cos theta like it is in the dot product formula. Let's have a look at the angle between a plane and a plane. This is just the angle between the normals for each of them. And you'll see that because they're both normals, the angles between the plane is the same. It ends up being the same as the angle between the normals of each of the planes. And so if you're pretty clever and by now you go, oh, so I'm guessing it's just cos theta, blah, 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 you'd be exactly right. The formula for it is cos theta, the angle between two planes, is equal to n1 dot n2. Again, magnitude of that so that we get the acute angle over magnitude of n1 times by magnitude of n2. And that's all there is to it. They're the two formulas for finding angles between either a line and a plane or a plane and a plane. Hope that makes sense. I'm sure you can substitute those values into different questions, be able to find angles between those. Enjoy.